Hey everybody, we're going over section 2-5 today. We're applying the remainder and factor theorems, which we're going to learn about, and we're going to be dividing polynomials. And there's two ways to do that. We're going to talk about long division of polynomials, and we're going to talk about something new. It's called synthetic division of polynomials. And I'm going to go ahead and show you a clip of a video that I've taught before, and then we'll come back and add some more to our fourth grade when you learned long division and you thought, oh gosh, I hope I never have to use this again. But now we're going to be doing long division of polynomials, right? And long division's like, I'm back. Okay, so here's the deal. This is why we're using long division of polynomials. If we know one of the zeros of f of x, okay, that means we know one of the factors or one of the zeros, we can divide f of x by the factor to find the rest of the solutions. One way to do this is by long division. So we're using long division if we know one of the solutions to find the rest. So for example, we're going to divide 6x cubed minus 19x squared plus 16x minus 4 by x minus 2. Remember, that would be a solution of x equals 2, but as a factor, we write that as x minus 2. Then we're going to factor the result completely. So here are our steps for long division. Step 1, we're going to make sure f of x is descending, and we're going to make sure there's a 0 for any missing term. So for example, if there wasn't an x squared term, we want to make sure we have a 0x squared there. We're going to set up the house. Remember, the numerator goes inside, and the denominator goes outside the house. So for us, when we're looking at this, number 1, we're making sure it's in descending order, which we see 6x cubed is the biggest term, and then 19x squared is the next 16x minus 4. So that is in descending order, so we're going to write it right here. 6x cubed minus 19x squared plus 16x minus 4. And there's no missing terms. And now we're going to set up the house. So we've got our house here, division, and we're dividing by this x minus 2 factor. Okay? Our next step is to divide the first term into the first term. So here's what that means. This first term, x, is going to go into 6x cubed. So what is 6x cubed divided by x? We know it's 6x squared. And I'm putting it here because this x squared is this x squared column, okay? Now we're going to multiply back where we multiply here to here. So we multiply back. After we divide, we multiply back. So we get 6x squared times x is 6x cubed. 6x squared times negative 2 is negative 12x squared. Now, step 4, we're going to line up the quotient, draw the line, and change the sign. And here's what that means. We're going to draw the line here, and now we change the signs on the bottom half, aka subtraction, like we used to do for long division. If we did this correctly, these first terms should cancel. If they don't, we've done something wrong. Negative 19 and a positive 12x is negative 17x squared. And now we're going to step 5, bring down the rest. So we bring down the 16x and we bring down the minus 4. And now we're going to repeat our steps again. So in blue, I'm going to go first term into the first term. I know negative 7x squared divided by x is negative 7x. And now we multiply back. Negative 7x times x is negative 7x squared. Negative 7x times negative 2 is positive 14x. Draw the line, change the signs. This first term should cancel, and we end up with 2x, bring down the rest, and now we repeat again. I'm going to do this time in purple. We're going to go the first term into the first term. 2x divided by x is just positive 2. And now we multiply back. 2 times x is 2x. 2 times negative 2 is negative 4. Now we're going to draw the line, change the signs. These cancel, so there's nothing left. That's a perfect remainder. And what we're left with is this is our quotient. So our answer is 6x squared minus 7x plus 2 with no remainder. So that's how we do long division. So some of you are thinking, oh, Mrs. Ells, that's so long. Is it too long? Okay, so here's the thing. If it's too long and you don't love that, you could ask yourself, well, is the factor in x minus k form, meaning that there's a 1 on the coefficient of x and then it's minus some number, okay? If it is, then you can use what's called synthetic division, okay? So synthetic division looks like this. We're going to set up this value of k that comes from x minus k right here. So whatever this number is right here, that value of k, so if it was x minus 2, we would put 2 in the value of k. So let's go back to that original equation where they asked us to do 6x cubed minus 19x squared plus 16x minus 4. And we're going to divide it by x minus 2. So if we're going to use synthetic division here is how we would do it. So we're going to check our divisor. Do we have it in x minus r form, which this is, or x minus k form? This is. Our value for k is 2. It's whatever comes after the minus sign. So again, if you saw x plus 2, it'd be a negative 2. Now that we've got k in the box, now you're going to write the coefficients only for your descending terms. So our coefficients are just what's in front of the x value. So 6, negative 19, positive 16, and negative 4. And those are descending. Again, we're not missing any terms. So we write the coefficient 6, negative 19, positive 16, negative 4. And we're going to skip a line, and we're going to write our bar there. Step 2, we're going to bring down our first term, 6. That was pretty easy. Step 3, we're going to multiply by the value of k. So we're basically, as we go 2 to 6, we multiply. And we put it right here. Now we add down. Okay, so as we do this part, now we add down. So we've got negative 19 plus 12 is negative 7. And now we do this again. We multiply here to here, which we multiply and put it in this spot. So we go 2 times negative 7 is negative 14. And then we add down. Adding down 16 plus negative 14 is positive 2. And then again, we multiply 2 times 2 and put it right here is 4. And then again, we add down. Negative 4 plus 4 is 0. Once this is our last number, this is the remainder. And we knew in this place, we were going to have a remainder of 0. And keep in mind, this gives me left, that we're left with. This is the number, this is the x term, x squared term, and so on. So we're left with 6x squared minus 7x plus. So one thing I wanted to add to the video that you learned about long division is, what if there's a remainder that's not a 0? So that's not a 0. So here's what you would do. Let's say you divided x minus 2 into, or x plus 2 into 3x cubed minus 4x squared minus 28x minus 16. Okay, we're going to do all this work, this long division, which I already showed you, and then we're going to end up having some, let's just say the remainder was 8. What do we do with that remainder? we are going to take it and add it right here and put it over whatever our divisor was. So whatever we got here from our long division stays, and we add our remainder over the divisor. So that's what you're going to do if there's a remainder. Secondly, when we talked about synthetic division, if the remainder equals to 0, then again, we know that whatever we were using to divide it with is a solution. That the x, whatever value for x we used, it is a solution or a factor if that's what we were testing for. So again, the magic number is the remainder of 0. That's how we know that it is a solution.